Hi, my name is Sukhmandeep Singh, and in this video, I'm going to solve this problem from Math 1061. So we have to prove or disprove each of the given statements. The first part is that for all d in positive integers, there exists some n in integers such that the floor of n plus 1 on d is equal to the ceiling of n on d. So usually in these type of problems, it's easier to check for counterexample as a first step, since if a counterexample exists and we are able to disprove the statement, that's a lot easier than trying to prove the statement. So if we take d is equal to 1, then for any n in z, we will have that the left-hand side becomes the floor of n plus 1 on 1. That's just n plus 1. And similarly, the right-hand side becomes the ceiling of n on 1, and that's just n. So since we know that n plus 1 is not equal to n for any n in Z, so the original statement is false, and we show that by counterexample. So that was easy to show. The second part is that for all n in Z, if 3n plus 2 squared is not congruent to 4 modulo 6, then n is odd. So the way to prove if-then statement is that we assume the if part is true and then try to show that the then part holds. Um, and important thing to remember for if-then statement is that these are equivalent to another form by their contrapositive. So if we try to write the contrapositive for this one, we might find that that's easier to prove than the original statement. So we will just do that. So the contrapositive for this one is that for all and in B, this part stays same as the original thing. Then for the next part, we do if n is even. So the second part becomes the first part, but with the with negation. And the second part in contrapositive is then 3n plus 2 squared is 1.24 modulo 6. So if we let that n is in C and suppose n is even, then we can write n as 2k for some k in integers. So now we have assumed the first part in contrapositive is true. We have assumed this, and we will try to show that this part holds. So if we write 3n plus 2 squared and we substitute n is equal to 2k, we will get that 6k plus 2 squared. And if we try to expand that, that becomes 36k squared plus 4 plus uh, 2 times 2 times 6k, and that's 36k squared plus 4 plus 24k. And if we write it in this way, we get 6 outside the bracket. That's a common factor. We can write it in this way. So since k was in integers, um, this bit 6k squared plus 4k is also an integer. So by definition, 3 and plus 2 squared is congruent to 4 modulo 6. This is just by definition because from this we know that 3n plus 2 squared is equal to 6 times some integer plus 4. So the remainder when we divide 3n plus 2 squared by 6 is 4. So by definition, that's just 4 modulo 6. So we have shown that the contrapositive is true for this. And if the contrapositive is true, that's just equivalent to the original statement. So the original statement is also true. So we have shown this statement is true by showing that its contrapositive is true. Thanks.